There is a profound stillness in the night sky. It is a quiet that settles over you, a weightless blanket of peace that stretches from the edge of your vision to the infinite. When you look up into that darkness dotted with the steady ancient light of stars, you are taking part in the oldest human tradition. You are an observer. You are listening to the whispers of the cosmos. For astronomers, for the casual stargazer, for anyone who has ever felt small beneath the Milky Way, this observation is a form of meditation. We watch the slow, predictable dance of the planets. We trace the familiar shapes of constellations, the same patterns our ancestors saw. And sometimes we spot a traveller. These travellers are the comets and asteroids, visitors from the cold, distant edges of our own solar system, or sometimes from much, much farther away. They are streaks of ice and dust, momentary interruptions in the cosmic stillness. We find them, we name them, and we watch them. And into this quiet theatre drifted a new visitor. We designated it 3i Atlas. The 3i told us it was the third interstellar object ever detected. Like Oumuamua and Borisov before it, this meant it was not from here. It was a true alien born in the darkness around another star wandering the galaxy for perhaps billions of years before it found its way into our neighbourhood. At first, it was just another faint point of light tumbling silently through the black. It was moving fast as expected on a path that would only cross our system once. Our telescopes tracked it, measured its light and made predictions. It was reddish lumpy and looked like a fairly standard if somewhat large interstellar comet. It was interesting certainly, but it was behaving as we expected. It was a guest and we knew the script for this visit. It would fall toward our sun, growing brighter as the ice on its surface began to heat up. It would swing around our star in a tight, fast loop. It would develop a beautiful tail of gas and dust, a temporary flag waving in the solar wind. And then gravity would fling it back out into the void and it would be gone forever. 3i Atlas began its journey inward. It passed the orbit of Jupiter, then Mars. It grew brighter right on schedule. It crossed the path of Earth's own orbit, unseen by the naked eye, but closely watched by our most powerful observatories. It made its closest approach to the Sun, what we call perihelion. It survived the intense heat and gravitational stress just as the models predicted. It began its long journey back out, heading away from the light, preparing to leave us. And then, something changed. The change wasn't sudden, it wasn't an explosion. It was a subtle shift, a deviation from the script that at first seemed like an error in the data. The first images that came back from the automated surveys were confusing. The astronomers who saw them probably cleaned their lenses, checked their sensors, and ran the data again. The data was correct, the visitor was not behaving. When a comet heats up ice and gas erupt from its surface in geysers or jets, these jets are usually messy, unpredictable plumes. But the new images of 3i Atlas showed something else. The object had developed new structures. They were jets, yes, but they were complex, organised and pointing in multiple directions at once, directions that had nothing to do with the simple physics of being heated by the sun. They were symmetrical, they were controlled. This was the moment the quiet observation ended and the urgent questions began. A whisper from the cosmos had suddenly become a clear, sharp signal. Teams around the world pointed every telescope they could at the object, and the more they looked, the less sense it made. What they found was a list of anomalies, a list of things that should not be happening. First there was the acceleration. We know that gravity pulls the object. We can calculate the pull of the sun of Jupiter of every major body in the solar system. We know exactly how fast it should be moving. But it was moving faster. It was accelerating away from the sun at a rate that gravity alone could not explain. We call this non-gravitational acceleration. Due to for a comet, this is a simple rocket effect, the ice turning to gas and pushing the comet forward. But the push was too strong, too steady. It didn't match the messy random jets of a normal comet. It was a smooth, constant extra push. Then its colour began to shift. For its entire approach, 3i Atlas was a dull, rusty red. This is a common colour for interstellar objects, the result of billions of years of cosmic ray radiation baking the simple organic molecules on its surface. It's a sign of incredible age. But as it moved away, the red faded. Over a period of just a few weeks, it was replaced by a deep, almost luminous blue. Not the pale blue of scattered ice, but a rich, impossible cobalt. Comets don't just change their fundamental colour. The red surface was its skin. To turn blue, that skin had to be gone. And then the strangest part of all the tale. As it left the sun, its tail of dust and gas should have been magnificent, stretching for millions of miles behind it. This is the signature of a comet. Instead, the tail vanished. It didn't fan, didn't blow away. It just stopped. The stream of dust and gas that had been flowing for months suddenly ceased. It was as if a faucet had been turned off. A comet without a tail is like a bird without feathers. It simply does not make sense. And in the place where the tail should have been, those new structures remained. Those complex multi-directional jets. They weren't the messy explosions of ice we expected. They were focused, they were precise, and they were still pushing. We have watched the skies for all of human history. We have seen comets come and go. We have seen them break apart, we have seen them fizzle out, and we have seen them light up our nights. We know their habits, we know what they are. But when was the last time you saw a comet behave like that? The visual hunt for 3I Atlas was just the beginning. A photograph, a streak of light only tells you that something is there. It doesn't tell you what it is. To understand the object, we had to move beyond our eyes. We had to listen. And the first true message, the first real clue, came not from a lens, but from an array of sensitive metal dishes pointed at the sky from the vast, silent Karoo Desert in South Africa. This is the Meerkat Observatory, a sea of receptors built to capture the faintest whispers from the cosmos. And as 3I Atlas swam through our solar system, Meerkat was listening. For a long time there was nothing, just the background static of the universe. But as the object neared its closest point to the sun, the astronomers at Meerkat detected a signal. It was faint, but it was unmistakable. They found a specific radio frequency, a fingerprint glowing at 1.665 and 1.667 gigahertz. To a radio astronomer, this frequency is as familiar as ABC. It is the signature of the hydroxyl radical. A hydroxyl radical, just two atoms, one of oxygen and one of hydrogen. You and I know it better as OH. It is what you get when you take a water molecule H2O and you break it apart. It is the ghost of water. This detection was electrifying. This was the smoking gun for the comet hypothesis. Comets are made of water ice. When a comet gets near the sunlight's energy, the ultraviolet radiation shatters the water molecules in its tail, splitting them into fragments. One of those fragments is hydroxyl, so 3I Atlas was releasing water vapor. Case closed, right, it was a comet. But the astronomers were thorough. They checked the signal again, and they found something even more remarkable. The signal was not precisely at 1.65 gigahertz. It was slightly shifted. This is the Doppler effect. It's the same reason an ambulance siren sounds higher pitched as it comes toward you and lower pitched as it moves away. The same thing happens with light. Because 3I Atlas was moving away from us at tens of thousands of kilometers per hour, the radio waves it was releasing were stretched out, shifting them to a lower frequency. The computers calculated the expected shift based on its orbit, and it was a perfect match. This was the proof. This OH signal was not just random noise from a distant gas cloud, it was physically attached to 3I Atlas. It was coming from the object. The data was clear, 3I Atlas was an interstellar comet, and it was shedding water. The celebration, however, was short-lived. As the excitement settled, the scientists looked back at their observation logs, and a deep troubling puzzle emerged. It wasn't about what they found, it was about when they found it. You see, the Meerkat detection, that clear signal of water, happened in early December, right as the object made its sharp, fast turn around the sun. This is called perihelion, its closest approach. But the team had also looked for this signal back in September. They had pointed Meerkat right at it and found nothing. Absolute radio silence. This is backward. Think about a comet. It is a dirty snowball that has been drifting in the cold, dark void of interstellar space for millions, perhaps billions of years. As it enters a new solar system, it is fresh. Its surface is covered in highly volatile ices, things like frozen nitrogen, carbon monoxide, and water. These ices are so delicate that they begin to sublimate to turn directly from solid to gas when the comet is still very far from the sun. A comet is typically most active, most brilliant on its first approach. By the time it whips around the sun and gets cooked by the intense heat, its most volatile, easy-to-release gases are already gone. It should be less active on the way out. 3 Atlas did the opposite. It was completely silent in September, when it was still in the cold zone, where a fresh comet should have been most active. It stayed dark, it stayed quiet, and then only when it reached its most blisteringly hot point right at perihelion did it turn on. It was as if a block of ice refused to melt in a warm room but suddenly began to steam and sizzle the moment you put it back in the freezer. It made no sense. This was not the behavior of a simple natural object. It suggested the outgassing was not a passive melting but an event. Something happened or something was done at perihelion. The mystery deepened when another team of scientists, led by Professor Avi Loeb at Harvard, decided to ignore the gas around the object and instead focus on the object itself. They wanted to know its temperature. They used infrared telescopes which don't see visible light. They see heat. By measuring the heat signature, the faint infrared glow, they could calculate the object's surface temperature. The numbers that came back were cold. The team's analysis, published in a hurried paper, concluded that the surface of 3I Atlas was approximately 230 Kelvin. Now, 230 Kelvin may sound like a large number, but let's translate that. It is equivalent to negative 43 degrees Celsius, or negative 45 degrees Fahrenheit. This was shocking. Remember where this object was. It had just completed a slingshot maneuver around our sun. It was closer to the sun than the planet Mercury. It was being baked by radiation. Any natural rocky object, any asteroid, would have absorbed so much heat that it should have been glowing. It should have been hundreds of degrees hotter. But it was cold, colder than an Arctic winter night. How could something be so close to the sun and remain so cold? The only way is if the object was extremely reflective. If its surface was like a perfect clean mirror, it would reflect away almost all of the sun's light and heat, allowing it to stay cold. But we already knew this wasn't true. The visual telescopes, the photographs, had already told us the object was dark. It was darker than coal. It was absorbing, not reflecting sunlight. So now we have a paradox. The object is dark, which means it must be absorbing heat. But its temperature is cold, which means it must be reflecting it. It cannot be both. And there was one more piece of data from that temperature analysis. It was in the way the hydroxyl gas was detected. The signal that Meerkat found the OH fingerprint was what scientists call a narrow absorption line. Let's imagine what that means. When a typical comet releases gas, it's a violent, chaotic explosion. Pockets of ice trapped beneath the surface heat up, burst, and shoot jets of gas and dust into space at high speed in every direction. This creates a broad signal. The gas is moving fast, it's messy. The signal from 3I Atlas was not messy, it was narrow. This means the gas molecules were all moving at a very similar and very slow speed. The gas was not exploding from the surface, it was leaking. It was as if it was being released gently, methodically. So let's pause and look at the picture we are building. We have an object that releases water like a comet, but it only releases that water at perihelion, not like a comet. We have an object that is physically dark like a rocky asteroid, but it is incredibly cold, not like an asteroid. It releases gas, but it does so gently in a slow leak, not like a comet. Every piece of data we collected seemed to contradict the piece before it. The object was a puzzle box. And then the final clue, the one that for many scientists broke the entire comet theory for good. This last piece of data came from the Atacama Large Millimeter Submillimeter Array known as ALMA. This is one of the most powerful and precise telescopes on Earth, located high in the desert mountains of Chile. ALMA's job was simple: pinpoint the exact location of 3I Atlas. In celestial mechanics, this should be easy. We know the laws of gravity. We have known them since Newton. We can calculate the path of a planet, an asteroid, or a comet down to a tiny fraction of a degree. We know where the object should be at a precise time. ALMA pointed its many dishes and it found 3I Atlas. But it was not where it was supposed to be. The calculations were precise, the physics was known, and yet the object was off. It was measured to be 4 arcseconds away from its predicted gravity-only path. Now 4 arcseconds sounds impossibly small, and it is. An arcsecond is a measure of an angle. There are 360 degrees in a circle. Each degree is split into c arc minutes. Each arc minute is split into st arc seconds. 4 arcseconds is the width of a single human hair seen from 20 meters away. It is an impossibly tiny margin of error, but in astronomy it is a canyon. Our models of gravity are so good that finding an object 4 arcseconds away from its predicted path is not a margin of error. It is a failure of the model. It means your model is missing a force. Gravity was pulling the object along one path, but something else was pushing it. It was undeniable. This was the non-gravitational acceleration. The object was accelerating away from the sun, but faster than gravity alone would allow. It was being pushed. At first, this seemed to support the comet theory. This is what comets do. The gas they release, the outgassing, acts like a tiny, weak rocket engine. The sunlight pushes on the gas and dust, and that force over time gives the comet a little push, nudging it off its gravitational path. This is normal. But do you see the final terrible contradiction? We had just established from the narrow absorption line that the gas release was tiny. It was a gentle, slow leak. A push of 4 arcseconds would require a massive amount of outgassing. It would require violent, powerful jets of gas. It would require a rocket. The data from ALMA said the object was being pushed by a powerful rocket engine. The data from Meerkat said the object was only running a tiny, gentle thruster. Both cannot be true. This is the central mystery of 3I Atlas. This is the riddle the data has given us. We have an object that is being pushed with the force of a powerful engine, but with an exhaust so weak it is barely a whisper. We have an object that is as dark as charcoal, but as cold as a mirror. We have an object that waits until it is in the fire of the sun before it decides to release its cloud of water vapor. The data had spoken, and what it told us was that 3i Atlas was like nothing we had ever seen before. The models were broken, the theories failed. We were looking at an object that by the numbers simply should not exist. And so with the data in hand, scientists were forced to ask a new question. If it is not a comet and it is not an asteroid, what is it? As we continue our slow, quiet drift through the darkness floating alongside this mysterious visitor, 3i Atlas, we arrive at the very heart of its puzzle. It is a gentle riddle, a quiet contradiction that left scientists on Earth feeling a deep sense of wonder and confusion. We know that 3i Atlas was accelerating. It was moving faster than it should have been, pushed by some invisible force. As it rounded our sun and began its long journey back out into the void, it was picking up speed, not in a sudden violent burst, but with a steady, constant and gentle nudge. Something was helping it along, pushing it away from our star. Now in the cold, silent theatre of space, this is something we expect to see from a comet. When a comet made of ice and dust swings close to a star, the warmth of that star is incredible. It heats the comet's surface. The ice doesn't melt into water. In the vacuum of space, it turns directly into a gas. We have a word for this. This is called sublimation. This gas bursts out from the comet's surface, creating beautiful, powerful jets. These jets of gas and dust act like tiny natural rocket engines. And just like a rocket engine, they push the comet. This push is what we call outgassing. It is the normal, predictable and understood way that a comet accelerates. It's how they get their speed. And so astronomers on Earth pointed their most powerful telescopes at 3i Atlas, fully expecting to see the evidence of this process. They were looking for the coma. A coma is the great fuzzy cloud of gas and dust that should surround an active outgassing comet. If 3i Atlas was accelerating this much, if it had rocket engines powerful enough to change its path, it must be surrounded by a massive cloud of this gas and dust. It should have been bright, obvious and spectacular. But when the data came in and the images were processed, the astronomers found almost nothing. The images were sharp, the data was clear, 3i Atlas was accelerating strongly, but it was missing its coma. The push was there, but the visible exhaust, the great cloud of gas, was absent. It was as if you saw a speedboat cutting through the water, but it was leaving no wake behind it, or hearing the sound of a powerful engine but seeing no smoke. This is the core problem. It is a profound and quiet riddle. How can an object have the power of a rocket without any visible sign of fuel being burned? The numbers simply did not add up. The observations did not match the theories. A normal comet would need to shed an enormous amount of water, ice and dust to get this much of a push. But 3i Atlas, it was clean, it was dark, it was moving silently, pushed by an invisible hand. This discrepancy, this gentle, persistent gap between what we see and what we should see, forces us to think. It forces us to wonder, to look deeper, and to open our minds to possibilities we might normally set aside. When the familiar answers no longer fit the facts, science does not simply stop. It does not give up. It just opens its mind a little wider. It draws the circle of possibility to include things that were perhaps once considered unlikely. A scientist named Avi Loeb, looking at puzzles just like this one, suggested a path of thought. It is a path that many find unusual, but it is a path born from pure cold logic. He proposed that when all the natural explanations, all the usual suspects like ice and dust and outgassing, when they all fail to explain the data, we have a scientific duty to consider the alternatives. He introduced the possibility, however remote, that the object is not a natural piece of rock and ice at all, but rather something made, something artificial. Now it is very important to understand what this means. This is not a conclusion, it is not a statement of belief, it is a hypothesis. It is a question. In science, this is one of the most important steps, asking what if our first assumptions are wrong, what if this isn't a comet? This idea is part of a search for what we call a technosignature. It is a sign of technology. For decades, astronomers have searched for biosignatures, signs of life like microbes or oxygen. A technosignature is just the next step, a search for signs of engineering of intelligence. The reasoning is quite simple. If 3i Atlas is being pushed but not by gas escaping from its surface, what else could be pushing it? One thing we know of, one thing we have imagined building that can move through space and be pushed without leaking gas, is a machine. Perhaps this hypothesis suggests the object is very thin and very large, like a sail, a solar sail. It would not be pushed by gas from within, but by the light of our sun from without. The gentle constant pressure of sunlight itself, solar radiation pressure, is a real force. It is very, very weak, but if an object is very, very large and very, very lightweight, like a piece of paper the size of a city, the sun's light alone could be enough to push it, enough to cause the exact acceleration we observed. A natural object like a rock or a piece of ice is almost never this thin and this light, but a made object, a sail built to travel between the stars, could be. Again, this is not proof. It is just an idea, but it is an idea that fits the data. It explains the acceleration, and it explains the lack of a coma. The scientific method demands that we test all possibilities that fit the facts, even the ones that feel extraordinary. So with this new, strange and wondrous possibility resting quietly in the backs of their minds, astronomers knew they had to look again. They needed more data. They needed to see if they could catch the push in action. And so the call was made. The most powerful eyes on and above the Earth turned their gaze toward 3I Atlas, the Hubble Space Telescope floating silently in orbit high above the blurring effects of our atmosphere, and the giant Gemini twin telescopes, one resting on a mountaintop in Hawaii, the other in Chile. They stared into the darkness. They gathered the faint photons of light that had travelled millions of miles from this mysterious visitor. The images that came back did not solve the riddle. In fact, they only made it deeper. The images were puzzling. They did show some material. There were faint ghostly wisps. This was not the great roaring cloud of a normal comet. It was something else, something subtle. These were not simple jets. A normal comet warmed by the sun will shoot its gas and dust away from the sun. The sun's heat and the solar wind catch this material and push it back, creating a single beautiful tail. But 3I Atlas was different. The images from Hubble and Gemini showed multiple jets, faint streams of material, and they were pointing in different directions. It wasn't a single predictable plume of gas, it was complex. And then, looking closer at the data, they saw the strangest detail of all. The most counterintuitive observation: one of these faint jets, one of these streams of material, was pointing towards the sun. Take a moment to let that sink in. The sun is the source of heat. The heat is what creates the jet. The jet should be pushed away from the heat source. A jet pointing sunward is like a fire burning against the wind. It is like water flowing uphill. It does not follow the simple logic of heating. What could this possibly mean? Perhaps there is the natural explanation. Perhaps the object is spinning in a very complex way, tumbling end over end. Perhaps the side facing away from the sun, the cold night side, still has pockets of trapped gas that are exploding. And as the object tumbles, this jet just happens to be pointing toward the sun when we took the picture. It's possible. A complex rotation, a chaotic spin, but it also opens that other door again, the one we were just peering through. If 3I Atlas was a machine, if it was a vessel, it would not have to follow the rules of a simple sun-heated rock. Its vents, its engines, could point in any direction they were designed to. They could be used for steering, for stabilization. A jet pointing at the sun would actually slow the object down, fighting against the solar pressure. But perhaps the other jets, the ones pointing away, were the true source of the push. Perhaps the sunward jet was just a small release of pressure, a stabilization thruster. The images did not give us an answer. They only gave us better questions. The jets were real, but they were not the jets of a simple comet. They were multidirectional, complex, and one was pointing the wrong way. 3I Atlas was moving faster than it should. It was doing so without a visible cloud, and the few small wisps of material it did show were behaving in ways that defied our simplest explanations. The mystery was only growing deeper, and the time to observe our traveller was quietly running out. Let us return now to this strange traveller. We have watched it tumble, and we have measured its strange and sudden speed. But as we look closer, as we zoom in with our most powerful instruments, the picture does not become clearer. It becomes more confusing. The story of this object is written in its light. Every visitor from the depths of space tells us who they are and where they have been by the light they reflect. It is a language of colour, but the language this object spoke was one we had never heard before. It seemed to contradict itself. This is the mystery of its colour. When we first saw it, when our telescopes first locked onto this tiny moving dot, it had a distinct colour. It was a deep dark red, Now this made perfect sense to us. Astronomers around the world likely nodded, perhaps with a sense of comfort. A dark reddish hue is precisely what you would expect. It is the colour of history, the colour of time. You must imagine an object travelling between the stars, not for 1,000 years or even 1,000,000. This object has been travelling for hundreds of millions, perhaps billions of years. For all that time it's moving through the galaxy. And the galaxy you see is not empty. It is filled with thin, almost invisible clouds of cosmic dust. Over these immense, unimaginable timescales, this dust settles. It builds up a crust, a patina, like a statue left in the elements for centuries. This cosmic dust is often rich in complex carbon-based molecules. We call them organics. And these materials, these building blocks of life, they tend to absorb blue light and reflect red light. It is the very same reason our own sunsets are red. When the sun is low in the sky, its light must pass through a great deal of our atmosphere. All the tiny particles in the air scatter the blue light away in all directions. That is why our sky is blue. But the red light it pushes right through. It passes through all that dust and air and reaches our eyes. We call this reddening. So for an interstellar object to be reddened by its long journey, or perhaps by its own dusty organic composition, this felt familiar. It felt natural. It told us this object was old, ancient, and that it had come a very, very long way. It was a colour we understood, but then something happened. Something that, to this day, we cannot fully explain. As we continued to watch it as it looped around our sun and began its long, fast journey back out into the dark, the colour changed. The deep dark red faded, and it shifted. It began to appear blue, or perhaps a blue-green. Now this is deeply strange. In space, solid objects do not just change their colour like this, and more importantly, they almost never shift from red to blue. The universe is full of processes that make things redder. That gentle reddening from dust happens everywhere, but processes that make a dusty, rocky object bluer, these are incredibly rare. It was a change that defied our expectations. It was as if the object had shrugged off its disguise. The familiar, dusty, ancient traveller suddenly looked new, or it looked like something else entirely. Our minds, of course, the minds of scientists, race to find a natural explanation, and there are possibilities. Perhaps the object was not just a dead, inert rock. Perhaps it was a comet. When a comet gets close to our sun, the heat is powerful. It warms the comet, and ices that have been frozen for billions of years begin to turn directly into gas. We call this sublimation. This gas streams away from the comet, forming a glowing cloud around it, a coma. And what colour does this gas glow? Very often it glows a pale, ethereal blue or green. This beautiful colour comes from specific simple molecules like cyanogen or diatomic carbon. When the sunlight energizes these gases, they radiate, they glow in these specific lovely colours. So perhaps that is what we were seeing. Perhaps the object got warm and it began to outgas just like a comet. The red colour was the dark, dusty surface, and the new blue colour was a cloud of glowing gas suddenly appearing around it. It is a good theory, a logical one. There is another possibility too. It is more subtle. It relates to the same reason our sky is blue. The effect is called Rayleigh scattering. It works like this: if you have particles that are extremely small, much, much smaller than the wave of light itself, these tiny, tiny particles get very good at scattering blue light while letting all the other colours pass by. Our atmosphere is full of tiny nitrogen and oxygen molecules. They do this perfectly. They grab the blue sunlight and scatter it everywhere, painting our entire sky. So what if the object as it passed the sun released a cloud not of gas but of dust? A dust made of incredibly fine microscopic grains. This cloud of blue dust would not glow on its own. It would simply scatter the sunlight and the object would suddenly appear to be wrapped in a blue haze. These are both plausible ideas. They are good science. But they both have a problem of timing. Why now? If this was a comet, why did we not see this cloud of gas before? Why did it wait until it was already past the sun and heading away from us to suddenly burst into colour? Usually comets are most active when they are closest to the sun at their warmest point. This visitor, it changed after that point, and if it released a cloud of fine dust, what force did it? What mechanism? It is not a simple thing to do. It is not impossible by any means, but it is particular. It is specific. The red to blue shift remains one of the object's most profound and beautiful puzzles. A change of costume right in the middle of the performance, leaving all of us in the audience wondering what the change means. And as we let our eyes adjust to this strange new colour, our instruments were busy. They were counting, measuring, analysing the numbers. And this is where the mystery deepens. This is where the puzzle truly begins to trouble us. Because the numbers do not seem to fit anything. First the age. Based on its trajectory on its path through space, we can trace its journey backward. We can ask what kind of star system did it come from? What neighbourhood? And the answer that came back was surprising. The data suggested it came from an older part of the galaxy. The object itself was likely born in a system that is much, much older than our own. Our solar system, our sun, our Earth, all of us, we're about 4.5 billion years old. We think of this as an ancient number, but the calculations for this visitor, they suggested an age of perhaps 7 billion years. Let that number just rest in your mind for a moment. 7 billion years. This is not just an object, this is a relic, an artifact from a time before our Earth even existed. Our planet was still just a cloud of gas and dust slowly coming together when this object was already travelling. This vast ancient age tells us something. It tells us that it comes from a different and more mature part of the galaxy, and it prepares us for the next strange number. The composition, the stuff it is made of. When we look at comets in our own solar system, they are what we call pristine. This is a word that means original, unchanged. They are like dirty snowballs. They are a jumbled mix of ice dust and simple rocks. They are the original building blocks of planets' leftovers frozen in time. A key thing about them is that they are not differentiated. Differentiated is a simple but very important idea. It is what happens when a new planet is first born, when it is very hot and molten like a ball of liquid. When this happens, the heavy things like iron and like nickel, they sink. They fall down through the lighter material and gather at the very centre to form a dense metallic core. The lighter things like rock float on top to form the crust. Our Earth is differentiated. It has a massive core of iron and nickel. The comets we know are not. They are just a jumble. So when we looked at this visitor, we expected it to look like a comet, a pristine, jumbled, dirty snowball from another star. But the data suggested something else. The readings were faint. They were difficult to get as the object was so small and so far away. But they hinted at an unusually high amount of nickel. This is a very, very troubling number. High nickel content is not something you find in a pristine comet. It is something you find in the core of a planet, or a very large asteroid. It is a sign that this object was not just a leftover piece of fluff. It is a sign that it was once part of something much larger, something that was hot enough to melt to differentiate to form a metallic heart. And then something must have happened to shatter that planet, to send this fragment, this piece of its nickel-rich core tumbling out into the dark. So what is this thing? Is it a comet glowing blue with its own gas? Or is it a shard of a shattered planetary core rich in metal? It cannot be both. The numbers are arguing with the colours. The story is contradicting itself. And this deep, unresolvable contradiction is what leads us gently, thoughtfully, to the final, most whispered about possibility. The probe hypothesis. Let us just for a moment entertain this thought. Not as a fact, not as a belief, but as a contemplation, a what if. What if this object is not a what but a who? What if it was built? Let's just follow this idea purely as a thought exercise as we drift. If you or a civilization far, far older than ours, a civilization that was 7 billion years old, if you wanted to build something that would last, something to send on an immense journey, a journey not of millions, but of billions of years through the dust and radiation of interstellar space, what would you build it from? You would not build it from soft ice or from crumbly rock. It would be eroded. It would be destroyed. No, you would build it to endure. You would build it from the strongest, most durable materials you know. You would build it from metal. You would perhaps build it from an alloy of iron and nickel. You would build it just like the metallic core of a planet because you know that those materials can survive for billions of years. And suddenly the troubling number, the high nickel content, it is no longer a contradiction. It is a design choice. Suddenly the ancient age 7 billion years. It is not just a curiosity. It is a testament to the builders. And the colour change. The strange red to blue shift. What if the initial red colour was not a coating of cosmic dust? What if it was a coating? A layer of material perhaps designed to protect the craft on its long, long dormant journey. And what if, upon entering our solar system, a system with a star, a system with planets, it did something? What if the shift to blue was not a natural comet-like outgassing, but a change in its state? What if the blue was the colour of its propulsion? A cloud of ionized particles, a plasma drive pushing it gently, helping it adjust its course, or perhaps just braking. Or perhaps the red shell was ablative, a heat shield. And as it passed our sun, this shield burned away, revealing the true blue-hued metallic body underneath. These are of course just dreams, just speculations whispered in the night. There is no evidence. There is no proof. It is simply a hypothesis, an idea that strangely seems to tie up all the loose ends. The age, the metal, the colour, it turns all the contradictions into the features. And so we are left suspended between two incredible and equally fantastic stories. On the one hand, a natural explanation. A messenger from a shattered planet, an ancient metallic asteroid that by sheer and utter coincidence began to act like a comet, changing its colour in a way we have never seen before. A story of extraordinary beautiful chance. And on the other hand, a story of intent. A story of a vessel, a suspect traveller, a probe, a relic 7 billion years old passing through our small sunlit room for just a few days before disappearing back into the darkness. We do not know, and perhaps we will never know, and that is the true mystery. It is a question left hanging in the void, a question that this visitor has left for us, a question to ponder as we drift and dream. And so the great object 3i Atlas receded. The tidal wave of global anxiety which had peaked just days before began its long, slow retreat. The world which had held its breath exhaled. On the news, on social media and government press briefings, the narrative quickly solidified. The immediate danger had passed. The official story was simple, clear and reassuring. It was, we were told, just a comet. A very large, very strange and very fast interstellar comet to be sure, but a comet nonetheless. A natural phenomenon. Frightening, yes, but ultimately understandable. NASA, the agency the world turned to, led this calming message at all. Their spokespeople like the professional and steady Sean Duffy appeared on every major network. The statements were concise. The event was, they said, a transient cometary body. The flyby was within expected parameters, even if those parameters were terrifyingly close. The message was one of relief and a return to normalcy. It became a strange cultural moment. The event was so large it transcended science and became a media spectacle. In an effort to calm the public, there was a broad public outreach campaign. You might have seen it. Even celebrities like Kim Kardashian were brought in to deliver messages of reassurance, to tell the public that the experts had it under control, that we were safe, that it was just a comet. The message was, the show is over, go back to your lives. And for many that was enough. We wanted it to be enough. We wanted to sleep soundly knowing the rock and ice monster from deep space was gone. But for some, the story did not feel finished. In the quiet that followed the roar of the flyby, new questions began to whisper. When the immediate crisis passes, the human mind moves from fear to curiosity. It begins to pick at the loose threads, the small inconsistencies, the things that were said, and more importantly, the things that were not said. This is where the second phase of the 3i Atlas story begins. It is not a story of a near miss. It is a story of information, of silence, and of a deep growing suspicion that just a comet was not the whole truth. The first voice to publicly question the narrative was one the scientific community deeply respects, Dr. Michio Kaku. He was not loud or hysterical. He was as always thoughtful. But his words carried weight. He appeared on a podcast late one night and he used a phrase that stuck. He spoke of unnecessary secrecy. He did not claim there was a conspiracy. He did not claim it was aliens. He simply asked, why is the data so slow? In an age of instant information, he argued the greatest scientific organizations in the world were being strangely quiet. During the approach, NASA, the European Space Agency and others were brilliant sharing data in real-time coordinating telescopes. But after the flyby, after the closest approach, the tap seemed to slow to a drip and then it shut off. Dr. Kaku pointed out that science is not about reassuring the public, it is about informing the public. And the public was not being informed. They were being managed. This unnecessary secrecy, he said, does more damages than any frightening truth, because secrecy creates a vacuum, and in that vacuum suspicion and conspiracy are born. He was right. The suspicion was growing, and it was focused on one place, one dataset, one moment in time. It was focused on the planet Mars. While the object was passing Earth, it was also passing Mars, and Mars, unlike the empty space of the inner solar system, is not empty. It is home to our robotic emissaries. It is our outpost, our eyes and ears on the red planet. And these assets, our orbiters and rovers, had a vantage point that no one on Earth had. They had a front row seat. As 3i Atlas swept past, it was observed not just from Earth, but from our fleet at Mars. The most critical instrument in that fleet was the Mars Reconnaissance Orbiter, or MRO. The MRO carries one of the most powerful cameras ever sent into space, the High-Resolution Imaging Science Experiment. You may have seen its pictures, stunning clear images of the Martian surface so detailed you can see the tracks of the rovers. On October 2nd and October 3rd, as the object made its closest pass to the seedier red planet, the Mars Reconnaissance Orbiter was perfectly positioned. It was tasked with looking not down but out. It was aimed directly at 3i Atlas. It took the pictures. We know it took the pictures. The observation logs were public, and those images would be the clearest, most detailed, highest resolution photographs of this object that humanity possesses. Where are they? This became the central question, the core of the doubt. NASA's official line was that the data was complex, that it was still being downlinked a slow process from Mars, that it needed to be calibrated, processed, and peer-reviewed. These are all reasonable explanations. They are the standard operating procedure for science. But this was not a standard situation. The world was not asking about a mundane rock. It was asking about the thing that had just nearly missed us, the thing that behaved so strangely, the thing that came from another star. A week passed, then 2. The data from the Mars Reconnaissance Orbiter was still being processed. The scientific community grew restless. The public, sensing the hesitation, grew suspicious. The images taken from Earth were blurry, obscured by the gas and dust of the coma. But the MRO images, they would have been different. They would have been close. They would have shown us what was inside the shroud. The silence began to feel heavy, and then the pressure began to build from a new direction. Not from scientists, but from Washington. Congresswoman Anna Paulina Luna, a member of the House committee that oversees the space agency, did what Congress is designed to do. She began to ask official questions. She sent a formal letter to the NASA administrator. The letter was polite, but the request was firm. It was in essence a formal demand for transparency. She requested the full unreleased data sets, not just from the Mars Reconnaissance Orbiter, but from everything, from the Perseverance rover. Did its sensitive microphones pick up any sound as the object passed? Did its weather instruments detect any change in the thin Martian atmosphere, any pressure wave from the other Mars missions? What did they see? The Congresswoman's argument was simple. This data does not belong to any single agency. It belongs to the American people and to the world who funded these missions. She noted pointedly the unique and critical importance of the Mars perspective. Earth was looking at the object's tail. Mars was looking at it from the side. Why Mars? Because it gave us a different angle, a different light. It gave us a 3-dimensional view. The delay of this one specific set of data, the high-resolution images from October 2nd and 3rd, was no longer a simple matter of procedure. It was now the key. Why? Why hold back the very best pictures? This is the question that hangs in the air even now. This is the heart of the doubt. If it was just a comet, you would show the pictures. You would show them with pride. You would point to the nucleus, the jets of gas, the field of debris. You would use them to teach the world. The only reason to hold back is if the pictures show something else, if they show something you cannot explain. Or perhaps if they show something you can explain, but you are afraid to. This is the silence that fuels the mystery. The official response was, "It's over." But the lack of data, the unnecessary secrecy, the formal calls for transparency, they all tell a different story. They whisper that the story is not over. It is just beginning. And we are all floating in this quiet, shared uncertainty, looking at the space between the official story and the official silence and wondering, what did the Mars Reconnaissance Orbiter see? What is on those images that we are not being allowed to look at? We have journeyed far following the path of this silent traveller. We have traced its discovery from a faint flicker in the Atlas telescope to a global scientific puzzle. We have explored the deep cold of interstellar space from which it came, and we have felt the faint warmth of our own sun as it drew this visitor closer. We have debated its nature, weighing the comfort of the familiar against the shock of the extraordinary. And now we find ourselves in the final part of this journey. We are in the present moment. We are in the time of waiting. This part of our story is called The Wait and the Wonder. It is a time of holding our breath of telescopes turning in unison toward a single moving point of light. It is a time where the grand, slow clockwork of the cosmos is about to reveal its next move. What we do in this time of anticipation defines who we are. We can choose anxiety, or we can choose to relax into the procedure. So let us settle in, let us breathe deeply, and let us review what we know and what we do not as we wait for 3i Atlas to make its closest pass. In the midst of all the noise, all the theories and the speculation, it is helpful to ground ourselves in the facts. What do we truly know for certain? First, we know that it is real. This is not a computer model, a software glitch, or a trick of the light. It is a physical object. It has mass. It occupies a specific point in space and time. It reflects the light of our sun, and that reflected light has travelled millions of kilometres to land on our digital sensors here on Earth. It is a tangible thing, a visitor that has physically entered our home. Second, we know that it is interstellar. This is perhaps the most profound fact of all. Its path, its velocity is what we call hyperbolic. This is a simple, elegant word that means It is not bound to our sun. It is not one of our family of planets, comets, or asteroids. It is a true outsider. Its origin lies in the deep dark expanse between the stars. It has travelled for perhaps millions or even hundreds of millions of years from another solar system at a place we can only dream of. It is an ambassador, intended or not, from another shore. Third, we know that it is approaching. As we speak, it is falling toward us. The date is marked on every calendar in every observatory December. This will be its closest pass to Earth. This is our one and only chance. It is not slowing down to stay. It is not entering orbit. It is a flyby. A close, fleeting encounter. It will greet us, pass us, and then continue on its journey, eventually leaving our solar system to return to the cold interstellar night. This proximity, this approaching date, gives our waiting a focus. And fourth, we know that its behaviour is strange. This is the heart of the puzzle. This is what separates 3I Atlas from Oumuamua, the first interstellar visitor we found. This object is not just a passive tumbling piece of rock. It has demonstrated non-gravitational acceleration. It is pushing itself, or being pushed by a force other than the sun's gravity, and this acceleration is not messy like a comet erupting. It is clean, it is precise, and as we will see, it seems to have begun. This list of knowns is short, but it is powerful. It leads us directly to the vast ocean of what we do not know. We do not know its true origin. We can trace its path back toward the constellation Sagittarius, but that is just a direction, a signpost pointing into the infinite depth of the galaxy. We do not know what star system it came from. We do not know its true composition. Is it rock? Is it metal? Is it a form of ice we have never seen before? Is it, as some have quietly suggested, a manufactured artifact, a piece of technology? The data is ambiguous, and because of this, we do not know the why. Why is it accelerating? Is it a natural process? A pocket of frozen gas warming and escaping, or is it a deliberate action? Is it propulsion? These are the questions that hang in the air, heavy and shimmering, as the world waits for December. This anticipation, this great wait, is not a passive event. It is an opportunity, and it is an opportunity for everyone. The arrival of 3I Atlas is not a secret. It cannot be. In our modern world, the sky is transparent. It belongs to no single government, no single agency. This is not an event happening in a locked laboratory. It is happening in the shared backyard of humanity. This December, when the object makes its closest approach, it will be the main event for every major telescope on Earth and in space. The James Webb Space Telescope will turn its golden segmented eye toward it. The Very Large Telescope in Chile, the Keck Observatory in Hawaii, all the giants of astronomy will pause their other work to stare at this visitor, but they will not be alone. This is the moment for the amateur astronomer. The person with a telescope on their balcony, the local astronomy club gathered in a dark field. In the age of digital cameras and networked computers, the line between amateur and professional has blurred. Amateurs make discoveries, they monitor asteroids, they discover supernovas, and with 3I Atlas, they all provide a crucial network of eyes on the sky. Thousands of smaller telescopes spread across the globe will create a continuous stream of observation. When the object is in daylight for the large observatories in Hawaii, it will be in perfect nighttime viewing for observers in Europe or Africa. This global collaboration ensures that nothing will be missed. It is a beautiful, spontaneous demonstration of human unity. We are all for this brief moment a single species looking up. This transparency is inescapable and it is wonderful. The data will be shared, analysed and debated in public. Science will happen in real time right before our eyes. We will all get to see the new images as they arrive. We will all get to share in the wow moments and the frustrating what is that moments. This event is a rare chance to see science not as a finished book of facts, but as a dynamic living process. It is a process of curiosity, confusion, argument, and finally discovery. This shared open curiosity is essential because the central puzzle of 3I Atlas remains unsolved. We must go back to that key mystery, the change in its velocity and the timing of that change. Let us revisit that moment. The object fell in from the void for millions of years, silent and dark. It was for all intents and purposes off. It was a dead piece of cosmic debris. It rounded the sun. It reached perihelion, that is the name for the closest point in its orbit to our star. This is the moment of maximum heat, maximum radiation, maximum solar wind. And precisely at that moment, it turned on. The acceleration began. The outgassing or whatever it is started. The object's entire character changed. It was no longer a passive rock, it was an active something. This on-off behavior is the riddle. The most conservative, most scientific, and most likely explanation is a natural one. Astronomers proposed the insulating crust hypothesis. Imagine the object is like a loaf of bread with a very, very thick, dark crust. Inside it contains primordial ancient ices, nitrogen, carbon monoxide, things that turn to gas very easily. As it travelled through deep space, it was frozen solid. The crust protected the volatile ices inside. But when it reached perihelion, the sun's intense heat finally became too much. The crust cracked. The ices underneath, suddenly exposed to sunlight, began to boil furiously. This boiling gas venting into space like steam from a kettle would act as a small natural rocket engine pushing the object and causing the acceleration we see. This is a good theory, it fits many of the facts, but it has problems. If it were pristine primordial ice, we would expect to see certain chemicals in the gas cloud around it. Our spectrographs, our chemical noses, should have picked up the signature of carbon monoxide. It did not, or at least not in the amounts we expected. And the acceleration itself, a cracking crust would be chaotic. You would expect bursts of gas fits and starts. The acceleration would be messy, but the acceleration of 3E Atlas is smooth, it is constant, it is controlled. This problem with the natural theory is what opens the door just a crack to a more unsettling idea. What if the perihelion, the pass by the sun, was not a destructive event that cracked its shell? What if it was an activation trigger? What if the object used the sun's immense energy? What if it was a solar-powered machine, its batteries dead from a million-year journey, that just used our sun as a refueling station to power up its engines for the next leg of its journey? This is of course wild speculation. It is not science. It is science fiction. But the data on our screens, the smooth curve of that acceleration, forces us to at least think the thought. The on switch was flipped. We just don't know who or what flipped it. And this puzzle, this deep mystery of the activation is now connected to one of the most famous mysteries in the history of astronomy. In 1977, a radio telescope at Ohio State University, nicknamed the Big Ear, was listening to the cosmos. It stared at a patch of sky in the constellation Sagittarius, and for 72 seconds it recorded a signal. It was not static, it was not noise, it was a powerful, intelligent-seeming burst of radio waves. It was so strong, so perfect that the astronomer on duty, Jerry Amon, circled the data printout in red ink and wrote one word, wow, the wow signal. It was a mystery. It came from a blank patch of sky. It never repeated. We have pointed our telescopes back at that spot thousands of times. We have heard nothing but dance. For nearly 50 years it has remained the single most tantalizing and most frustrating hint that someone else might be out there. Now let us return to 3I Atlas. Scientists traced its path backward to see where it came from. The origin point, the direction it came from, is in the constellation Sagittarius. And when they mapped its origin point against the origin point of the 1977 WOW signal, they found that they were in the same tiny patch of sky. Not just the same constellation, but within 9 degrees of each other. In the vastness of the heavens, this is not just a coincidence. It is a stunning, statistically shocking alignment. It is as if someone mailed a postcard in 1977 and now the sender is flying past our house. But the connection grows deeper. As 3 Atlas activated around the sun, it didn't just start to move, it started to talk. Very faintly, our radio telescopes, the descendants of the Big Ear, began to detect emissions, structured pulsed signals. They are not natural static. And the frequency of these signals, they are centered around 1.665 and 1.667 gigahertz. To a radio astronomer, these numbers are sacred. This is the hydroxyl line. Hydroxyl is 1 atom of oxygen and 1 atom of hydrogen. It is 1/2 of a water molecule. Decades ago, scientists theorized that if a civilization wanted to broadcast its presence, it might broadcast at the water hole, the quiet patch of the radio spectrum between the hydrogen line and the hydroxyl line. The 2 components of water, the basis for all life as we know it. 3 Atlas is broadcasting in the water hole. So let us summarize. A mysterious object appears, coming from the exact direction as the most famous alien signal in history. It then activates by our sun, begins to accelerate with a strange smooth force, and starts broadcasting a faint, intelligent-seeming signal at the very frequency we associate with life. Is this a coincidence? Perhaps. The universe is a very large and very strange place. Coincidences are bound to happen. It could be that the signal is just a natural complex magnetic interaction. It could be that the alignment with the WOW signal is just a quirk of probability. This is the most rational, most likely explanation. But It is also a coincidence that demands our full attention. It is a coincidence that makes the skin tingle. It is a coincidence that is worth pondering deeply as we wait for the December flyby. And this is where we find ourselves in this quiet moment of reflection. The story of 3I Atlas is not just about astronomy. It is not just about a rock or a signal or a theory. It is a story about science itself. It is a story about curiosity and what it means to be open to the unknown. There is a great debate in science right now, exemplified by figures like Avi Loeb, the Harvard astronomer, who studied Oumuamua. The debate is about intellectual courage. Science is not a set of beliefs. It is not a dogma. It is not a collection of facts that we must defend. Science is a method. It is a process for asking questions, for being skeptical, and for following the evidence wherever it leads, no matter how uncomfortable the conclusion. For decades, the scientific community has been very conservative about the idea of extraterrestrial life. This is a good thing. We must rule out every single natural explanation first. That is the scientific method. But 3I Atlas is testing that method. It is pushing us. It is presenting us with a set of facts that are very hard to explain with conventional natural means. This is a moment that calls not for dogma, but for openness. It calls for us to be humble, to admit what we do not know, to be willing to have our entire view of the universe changed. This object, this 3I Atlas, is a mirror, and in it we see our own hopes, our own fears, and our own profound loneliness. Whether it is a comet or a craft, a natural wonder or an artificial message, its function for us is the same. It is an opportunity to contemplate our place in the cosmos. It is a reminder that we live on a small, fragile blue world in a solar system that is not isolated. We are part of a vast interconnected galaxy. We are not alone, even if our only neighbours are the silent wandering comets from other stars. The universe is vast, but it is not empty. It is full of travellers, and for a brief moment our path is crossing with one of them. So as we wait for December, there is no need for panic, no need for fear. This is a moment for wonder, a moment for quiet contemplation, a time for all of us together to simply look up. We are about to receive a visitor. We are about to learn something new about our universe, and maybe, just maybe, about ourselves. So as you settle in tonight, as you let your mind drift, think of this object. Picture it sailing silently through the beck on its way to its meeting with Earth. Let the scale of it all wash over you, the millions of years, the trillions of kilometers. The mystery is not something to be solved in a hurry. It is something to be relaxed into. It is a vast cosmic story, and we are lucky enough to be alive to witness this chapter. So let us keep observing, let us keep asking questions, and let us relax together in the grand, beautiful, and unfolding mystery of it all.